Flow Grid, Flow Safe, Flow Max training. Next, we're going to switch gears real quick to that regulator line that I mentioned was the fit for the gap set.
Jeff, you might want to clarify from before the flow grid
Thank you very
valve
much. Okay.
and say operator monitor. We don't do that.
Let me just use it in more of a, like the lesson in more of a general way. The point was brought up when we did sizing that it's important to consider when you're doing your sizing that the most critical from the perspective of ensuring you have adequate capacity is your minimum anticipated inlet pressure. So we just picked in our scenarios before when we did the sizing just an inlet pressure. But if there's a range, if there happens to be a range in the instance that we described where the inlet pressure, like in that morning in February that I talked about, could cause the pressure to drop, we want that valve to be spec'd so it will perform well in those situations where, because of lower inlet pressure, it's going to need to have more capacity. And so that will become part of our sizing. Now, I also need to consider what the MAOP is, because if there's a chance that the inlet pressure could be higher, then I've got to look at it from the perspective of more than anything with the flow grid, because the rangeability is so tremendous. It's more just, do I have enough differential pressure across the body under normal sizing to ensure that I don't exceed the manufacturer's recommendation. So for the 2-inch large ports that we were messing with in there, I know that if my inlet pressure could be 1,000 pounds and I was trying to cut to 150, and if one of those regulators had to do a 1,000 to 150 pound cut, that would exceed the normal 800 pounds that the regulator should see as a differential pressure. And I would need to deal with that in another way, such as making another initial cut upstream of this set, to take some of that pressure away. So it would take actually 2 failures to see kind of the non-standard emergency situation of more than the 800 pounds across these valves. So both the minimum, certainly from the sizing, that's most critical, and the maximum from a differential perspective, max differential perspective. Thank you for bringing that up. Okay, so we're going to talk about the FlowMax. Let me get back in the picture here. Okay, this is a 2-inch FM1T, they call it, FlowMax. The T stands for travel indicator, because in this particular model, there's a pin that's attached all the way down the shaft, the stem of this regulator, that when the valve is open, I get a position indication that comes up and shows me the valve is open. Kind of a handy little deal. That's the way we stock them. We don't stock them without them. But if someone had a preference and they did not want that feature, it basically gets capped just like that. So it fits there in place. So there's no valve travel indicator. The stem just doesn't have that piece attached to it, and it looks like this when it's on. It basically travels up and down to show me the position of the valve, and this gets attached to the end of the stem. There's a nut that attaches to, and so it kind of like the Pilot, it has an O-ring seal that it passes through and a bushing to help guide it. But that's all it is to the valve travel indicator. Okay, so this is, now they make high pressure versions of this now. They have HP FlowMaxes that they've designed, but the FlowMax that's been basically in our stock and around for years is a 150 class solution. It's intended for meeting requirements for a real high flow and also performing really well in low differential situations. Let's talk about the low differential first. It can go full open with as little as 3 pounds of differential pressure. That's full open. So you can set it as a relief at 3 pounds. You could make those pressure cuts from 60 to 55 without any issue. You can also do the same things you do with the flow grids as worker monitors. Their bodies are literally the exact same width, 10 inches in the 150 class range, 10 inches here. So again, a stocking choice for us, because the end connections can come in 2-inch NPT. It's an FM2, flat face flanged, which is an FM3, or this raised face flanged, which is the FM1. We stock a few FM2s. We don't stock any FM3s or any of the other flat face options going up in body size. The body sizes are 2-inch, 3-inch, 4-inch, and 6-inch. And literally a 6-inch FlowMax can do what an 8-inch flow grid can do capacity-wise. So you're able to stay down in body size with when you're using one. And so we didn't see the need to typically stock a flat face regulator. And we like the idea that it's a 1-for-1 exchange. If you're doing planning and you know that it's a flow grid or a FlowMax for my job, and I know the overall length of the body for that 2-inch or that 3-inch or that 4-inch flow grid, when you go to the FlowMax as an option, you don't have to change anything. It drops in the exact same width because we're doing a raised face, because all the Mooney flow grids are raised face, flanged if they are flanged. If they're not butt weld or NPT or something in the smaller sizes. So the 3 PSID to go full open is wonderful. The other thing about it is the capacity. This FG29 right here, Drew, can you pan over? Okay, that I was taking apart. This FG29. There we go. Okay, we mentioned that it had a capacity with 100% plate of 1420, and how much better that was, that we had to accommodate for that if we didn't want all that capacity when we were going from the 2-inch standard port, which is only 1130. Well, if you need more capacity than that, or you end up having to bump to a 3-inch valve, this, back over to the FlowMax, has a CG of 2250. So it's giving you vastly more potential capacity through it. Okay, so what are some of the limitations? We talk about limitation of differential pressure with a flow grid. We needed some. The limitations here are, at least with this body style, it's a ductile iron body. They are making some cast steel ones, so we actually got a couple coming into stock, kind of as another option. But because it's ductile iron 150 class and the way it's designed, the maximum inlet pressure is 250. So it is obviously ANSI 150 flange connections, but I can't go to like 280 on the inlet under normal conditions. That's one thing. The other thing is a turn down. Okay, because it doesn't have the step drill hole throttle plate with the peel away diaphragm and the accordion style spring, more of a traditional orifice and a plug seal, it has less rangeability than the typical flow grid. But there's a lot of things we can do to make it substantially better. I'll get into that in a minute, but I've got what essentially is the FlowMax version of throttle plates right here. In a minute, we'll go into it and look at them. Okay, so other things about this, it's a directional body. So when we are talking about, okay, left hand and right hand runs, I can do that with a FlowMax, but what I do is I turn the actuator around so that the pilot is on this side. What I don't get benefit from, and it's kind of like the A mounting I was talking about earlier, is I still have this body port that I can't move to the other side for my left-hand run. I'm going to have to tube over to it. If I'm mounting a filter on a post, or we're putting a bracket on here so that we're tubing over to a filter which is on the other side, we'll custom make it where all the components are on the left-hand side, but it's the body that has to go a certain direction with this one. Okay. You'll notice too, there are 2 big ports on the top of this valve, Both of those are in a common chamber sharing the top side of the diaphragm, okay? And you'll also notice that the pilot, same rebuild kits, same springs, but the loading port is blocked. It's got a plug in it right here. So you notice that. So the reason is, oh, well, and the third thing you'll notice, there's no restrictor on the inlet side of the pilot filter, or the pilot. The reason is because while the flow grids are an unloading style, I have to unload gas off the top of that diaphragm to get the valve to open, let the underside pressure on the inlet win. In this case, it's just the opposite. It's a loading style. So what I get is, if I have 200 pounds on the inlet, like we were talking before, it's trying to get up through an orifice we're going to look at in a minute. It's also coming through the pilot filter, coming straight through the pilot. Oh, wait, it can't come straight through the pilot because I got my loading port blocked. So it has to wait for the pilot to tell it to do something. So the valve's going to stay closed, waiting for the pilot. Let's say I set my spring pressure and push the plug and stem off of its seat. When I do that, it's going to put gas through the outlet. Instead of unloading it off the top like a flow grid, it's going to load it underneath, and it's going to basically lift the whole diaphragm with the stem and everything attached to it up and cause the valve to open. Okay. One of the other things that you're going to see about this and the way it balances, because we said, well, the restrictor helped to constantly be ready to close the valve whenever the pilot told it to stop. Well, that's happening here too, but it's happening in a different way. And it does have a restrictor, it's just not evident. Okay, the one thing that I'll show you in a minute is that the stem that's connected to all this is hollow. So that inlet pressure at 200 pounds is coming immediately up into this chamber with a piston that's exact same size as the orifice that allows pressure to be exerted down to give that closing bias. And when the valve opens, there's a pin right here between the upper and the lower chamber. So when that pilot lets gas into that lower chamber to lift the valve, it's constantly coming through the pin trying to reclose it. So I've got that same scenario where when the pilot finally stops letting gas into that chamber below to lift it, it quickly equalizes, and I've got that inlet pressure helping to shut the valve and a spring up here and a piston that are closing it down, and the valve goes close very quickly. Okay, so you don't have to really do anything as far as adjustments with this, but there are a couple of different pin sizes if you had a certain speed of response, speed of opening or speed of closing that you were concerned about. But it's pretty fantastic at both, so you're not likely to need that. Okay, so that gets us into then why you have these two ports here and why the sense port on the pilot, which is typically going downstream, is going into this chamber. Well, this would be the configuration of the FlowMax that would be a standalone regulator, or it would be the downstream regulator in a worker monitor set, where I could take my sense line from this port right here and run it downstream, my 8 to 10 pipe diameters. So it's indirectly that my pilot is getting the sense information. It enters this chamber on top, which basically causes that to be felt by my pilot sense point, and it responds either to open or close the valve depending on what it sees the downstream needing. Okay, so this is also something you don't have to do with this regulator ever if you don't want to. You could do it differently, and you're going to have to do it differently if it's a relief or it's the upstream regulator in a worker monitor. I'm going to get rid of this piece of tubing right here. This is the way the factory does it, by the way. Okay, this is the factory configuration. And their IOM manual discounts an important thing about the way any of these regulators could possibly fail, which is partly open because you get trash on the plug and stem or between the plug and stem and the orifice, debris build up, and you get leakage into this area under the diaphragm. If that happens under the description that we just made of, okay, well, it leaks into this chamber, it's going to mean it's going to provide some lift and get the plug off of the orifice, and it's not going to be fully closed. Even if the pilot's trying to get it closed, there's still gas coming in here. And where will it go? If my sense line is from here, this top chamber, like that, and this is the upstream valve in a worker monitor, and this valve isn't really closed, I've got gas from this top chamber that's bypassing my second regulator, and so the pressure downstream will build up, even if the downstream regulator is completely shut off. So that can't be, and so one of the things we point to, even in their IOM manual, is this has got to go. Take your sense line in a very traditional way, and this could be for all of them. It doesn't have to be just for the upstream regulator or for a relief, but just take your sense line from here downstream of your second regulator. You know, just do it like you do on a flow grid. What you do instead with this, then, you don't need this, just plug it. Plug it with a 1/2-inch plug. You still need something from here though, and that is between these two regulators, you need a return line. And this is because what would be happening in that instance is when the gas is flowing into this and lifting the valve, you've constantly got gas coming to the top side. Well, we want that to rejoin and basically balance with the downstream pressure, but between the valves, not around the second one. So we want to run a return line here that basically lets that gas rejoin with the downstream gas and not bypass our defense on the downstream side. So you would use this one, but as a return, and you'd run your sense line downstream your second valve from this one, and that would be plugged. Same thing if it was for a relief. If it was a relief, like any Mooney, all I got to do is change the orientation of the components in this pilot from pressure reducing to back pressure, so that the tension put down on the pilot is keeping the valve shut until the upstream pressure, because this sense line now goes upstream, until the upstream pressure gets high enough to let it pop off and let it start to relieve. So in that instance, all I'm doing is, like any flow grid, changing the orientation of the cartridge components, running my sense line upstream, and I need to have the gas that when the valve is relieving is coming from this port right here, re-enter, you know, go with the exhausted gas out the relief stack. So just a place to let that go. There are some people that just put a bug screen or something here on the relief. I mean, it won't not work, but you know, typically I'd recommend, you're gonna have a relief stack anyway, just have a return line into that. So when the relief does open, you've got a place for that gas to go with the relieving gas. Okay, let's open it up and take a look at it. One of the things that's a little bit intimidating about this, because it looks like a lot more things to maintain. It really doesn't. You know, with a flow grid, the thing you're getting in and maintaining more than anything is this diaphragm and any wear on it, and the little plug and stem assembly that's in the pilot. So this little piece right here, this little popsicle looking thing, as it gets wear on the pilot and its little orifice, those are the two places that a technician typically has to go if there's any issue with the valve not fully, you know, locking up where it's supposed to, you know, partially open, you know, situations. It's going to be one of those two places that they're typically going to find there's debris or wear that they got to fix. Okay, well, pretty easy. Well, this is easy. It just doesn't look like it from the outside. But to get to the things that I want to look at and maintain, I have to take off my inlet line. So I do have to take off a couple lines here, because like the A-mounted flow grid, I do have to take off the sense line. I do have to take off my inlet line so that I can get in here and play with it. I got 2 bolts, and when you get up to 6-inch, you have 4. You know, so the bigger ones, you got a couple more bolts, just up to 4, that hold the actuator on the body. All right, let me get those off. And there's a weather seal. It's almost like a neoprene gasket that just sits between the body and the actuator, but it's not a gas seal. It has an O-ring gas seal. Okay, so you grab the body. All right, so he's holding it so I can pull up on it. So here's that neoprene gasket that just forms a weather seal. And inside, start there. Inside, you'll be able to see a cage, which is just a spacer that allows me to keep the orifice down by having it push against the bottom of that actuator. Keeps the orifice on its O-ring that keeps it seated. So I have an orifice like that, and I have an O-ring in there that's like the O-rings in there. It keeps the gas from escaping around the path I want it to travel, and it has to travel through the orifice. That's where I want it to go. So what I get, this is the same orifice, is a situation where I have a plug seal. You can see it right here. Okay, that's the actual seating surface on the orifice. So that's where it's shutting off. And you want to talk about why it has so much flow in less rangeability. When this thing opens and it comes off of its seat, it's just got like wide open flow coming through. And I know that it's open because I told you guys about it, was watch when I push down on that whole assembly, what happens to this valve travel indicator. See it come up? Okay, so that's what's happening basically when the valve is lifting off of that. Okay, when I get that gas pressure coming up. Okay, so I get this little plug seal and I pick one of these plug retainers that sets the capacity. So if I have that in there, it's just basically 100% capacity, normal FlowMax with probably somewhere in the range of like 15-to-1 turn down, not great, okay? And it sits down on that like this, the plug seal, and keeps the gas from escaping up and over until this lifts up, until it lifts up like that. If I want to change the capacity though, or I want to change the rangeability, these are my throttle plates, so to speak. This is called a low flow range extender. Find where I'm getting the camera. This would be a 75% capacity plug retainer. This would be a 50% capacity plug retainer. And I can even reduce the overall capacity to 25% because I want to make that pressure cut. I'm making a 5-pound cut, so I want this valve, but I don't want all that capacity. So I can do it that way. It's as easy as this to do your maintenance. Okay, so I need to hold the stem right here. There's a slot on the stem. Here, you can see it. And I would hold that. I've got this nut loose, so all I got to do basically is hold it with my hand. But I hold it because I don't want it to be turning. Remember, I said everything's attached to it going up. So I keep a grip on it. I keep a hold on it, and I take this nut off the end. And then I have access to change my plug retainer. You might need, if it's been in there a while or whatever, it might be sticking to that plug seal. So you might need to just gently nudge it out with a flathead screwdriver, but just take it off. And you can inspect the plug seal, make sure that there's no wear, damage, or anything that's keeping it from sealing. You could also look at the edge of the orifice, make sure it didn't got hit with anything and a nick or something's causing it to leak. They come in, we have them by there's dozens if you have ever an issue with the stainless steel part or the plug seal. So this is like your diaphragm. When it gets wear, you replace it, but you don't, kind of like the diaphragm there where I said, well, you could flip it over and use the other side, the inlet side for the outlet and get a new surface. You can flip this over, get a new surface there. You're like in a pinch in the field, they're not going to have to like come up with another plug seal. They just flip it over and they get a fresh surface. And then to change the capacity, let's say I wanted to use this, what I call low flow range extender. The low flow range extender allows me to get up to control down to 1% of its rated flow. So 100-to-1 turn down. Okay, what it's doing to give me that low flow control is, here's my orifice again. Now, let's just assume that this was on that main shaft. When it sits down, it's shut off. But when it goes to open, the first part of it, it's very tightly milled to the inner walls of that orifice. So until it gets to that point, it's controlling low flow. It's just basically throttling it until it gets up out of the way. So a low flow range extender will take away 15% of the top end capacity. It'll take it from, 2250 down to 1900 something. It's still greater than the comparable flow grid in capacity, but it gets me a lot more low flow control when I need it. Okay, and the same thing, if you like the extreme side of it, if I had a 25% capacity plug retainer in, when it shut, it's shut, but when it lifts, it's never going to get fully out of the way. This thing only lifts like fully about like a half an inch, a little bit more. So it's never going to get out of the way. It's always going to be in the way of the gas that's trying to get through to limit my capacity. So that's how those work. And it's as easy as that to do most maintenance. Why do I not have to change the diaphragm or the rebuild kit looks like this. Why do I not have to change that and, the body O-ring and stuff? Because they're not under constant high velocity gas. It's just, they're just balancing. They're just constantly moving in a very small amount, up and down. And they're not experienced. There's no exposure to the diaphragm. You notice that when the gas comes through here, it's just passing through on the underside, and the chamber that we're talking about, the pilot filling with gas, is not exposed to the gas that's flowing through in the body on the underside. There's no way that anything in there is anything but just small balancing of pressure between the top and the bottom. So, it's going to go several years before you have any concern about, well, we might want to put a rebuild kit in. Okay, so this is the rebuild kit. You want a few of these around in case you have an issue and you want to, get a good shut off again. Is just a plug seal. Okay, so I guess I'll stop there real quick and see if there's any questions about the FlowMaxes.
Could you pick up the low flow range extender again so I can see that?
Yes. Okay, and then I will put, so it goes like that on the plug seal and would fit here like that. And then would just replace that 100% one. Okay, so I would just attach it here. And then when it goes down in the Mooney, it would sit into the orifice instead of on the orifice. So it's going to be about that range right there before it actually gets up out of the way.
Okay, so it's similar to the Census V port.
Not familiar with that.
Okay.
Sorry. I'll take your word for it. Any other questions? I mentioned that you could use the same pilots. One of the pilots that sometimes comes into play with a FlowMax that's playing with lower pressures is a Series 20L pilot. So the Series 20L pilot on any of this stuff gives me the ability with a bigger diaphragm to get a lot better control over a really low pressure set point. So 5 inches of water column, up to 8 pounds. So there's a transition between the 20L pilot and the standard Series 20 pilot, because my red spring in this will give me 3 to 12. And the most I can go with this one is 8, but I can, like I said, go all the way down to 5.5 inches of water column. So you'll get in a situation where you ask yourself, I'm setting 3 or I'm setting 4 pounds and I want to control it and I want to tightly control it. Well, if tight control is necessary, I would suggest that, just because that bigger diaphragm gives you a lot more sensitivity to small changes in pressure. And so it could be mounted on a FlowMax. A lot of times they are mounted on a FlowMax, or equally well on a flow grid. Okay, it may be the only time too when a Series 20L pilot might be considered for relief, because they don't even have the model number in the catalog to make it a relief, but it can be made a relief just as easily as any of the other Mooney pilots, because it's all in the cartridge. And because this thing can go full open with 3 pounds, you could set 4 and have a fantastic high capacity relief that could be, very accurate. All right, any other questions about FlowMax.
The low flow range extender is used with any of the other.
Yes, any size. So they come in the 3-inch, 4-inch, and 6-inch models, and they all have that same capability. That I can change out the plug seals, they call them, or excuse me, the plug retainers, and give you a difference in the way it performs. Either reduce its capacity, extend its range, you know, a little of both with the LFRX.
On the top part of the diaphragm where you had the 2 ports, and one was yes. One you said was for both of those ports. Are they switchable, or can they?
Yes.
Does one completely different than the other, or are they both the same?
They both are access to the top of that diaphragm chamber. So if it's more convenient for you to run your return line from this one and plug that one, then that's no problem. You know, all I wanted to make the point of is when it's in the situation where, you know, it's either the upstream regulator and the worker monitor, or it's the relief, then you need to run your sense line from here, not the way that it, you know, would come to me from the factory. I'm going to get rid of that, because this is where you should run your sense line from. This or this, one of these two, should be plugged. And then I need, you know, you to have the ability to run a return line between your upstream regulator, whether it's the worker or the monitor, into that interstage piping, or the inner piping. And then, you know, so that way the sense line can come directly downstream of your second regulator instead of indirectly from here. Okay. And that would go down as the you know, the sense line, and you'd have no return line in that instance. Okay. Of the upstream regulator.
So the return line serves to equalize the pressure, much like with the small port on a CL34 constant loaded regulator.
Yes, it does allow you to equalize this top chamber with what is downstream. So when it's basically sitting ready to work and the valve is closed, and let's say your set point was 30 pounds, there's 30 pounds in that downstream piping, and there's 30 pounds up here in this top chamber. Basically waiting to have gas from the inlet side join it, because the valve's being lifted up by that higher inlet pressure, and the restrictor is trying to equalize it as that's going on, but it can't, because it's not going to provide sufficient volume to beat the pilot dump or loading that gas underneath. I said dump. I had a Freudian slip with the flow grid. It's a dumper here. This is a lifter there, which is why I don't have that loading port on the pilot. And you can use valve spec to size these too. And if you tell me you're doing a worker monitor, we're going to certainly configure at least one of these the way I'm describing, where I know that you're going to want to run your sense line from the pilot here and plug one of these already for you, and then leave you probably this one, because it'll be in line, closer to in line to run your return line between the two valves. And again, if you said I'm speccing this because I want a high volume relief, then I'm going to plug one of these, and I'm going to leave that as the return line into the relief stack. And I know you're going to run your sense line upstream directly from the pilot. And that's the way that it would be piped. The only time that their configuration actually doesn't give you a possible scenario where it could cause you trouble is if it's a standalone regulator, or if it's a second regulator in a worker monitor. Then you can leave it the way that they typically would show in a picture. Okay. Otherwise, it's no-go, because we know that there's possible ways that these things can fail, and they're not accounting for one of them. Anything else? Obviously, I wouldn't have a green spring in these, because I'm not going to be able to set higher than 247 because my inlet pressure max is 250. So my downstream set points or my relief set points I'm talking about with it are going to be in that range, unless I go to an HP Flow Max, which is a new and different story. But so I'm going to have nothing more than a black spring probably in one of these. I'm not going to typically then have to worry about if I see one of these with the anti-crush ring that's typically on a Mooney Pilot that is high pressure, so that they don't snap the real high pressure spring. What I'm talking about is, here's a series 20H Pilot with that spacer that doubles the green spring range. And it has an anti-crush ring there on the stem, so it can't go down and break that real heavy spring that is allowing you to get the 200 to 450. So if you have any situation where that's not something you guys probably typically deal with, it'd be more of the text, but if they had that in there and they're having a problem setting a value that's either high or low, typically if they can't get the high enough on their spring range, if they have this in place and they have like a blue spring or a purple spring, they need to take it off. Sometimes it happens when they've like changed set points and they've crossed over a spring range or something. But
Jeff, when will the height HP Flow Maxes be available?
they're available now. Unfortunately, the lead times are aplenty. We will eventually be able to eliminate that for you when we start to stock them. But, you know, it's an evolutionary thing for us too. We can't have, you know, a $10,000 valve sitting in our warehouse for 2 years while we're waiting for somebody to need it. So it's not part of our current stock, and we are speccing them when someone says that they have something, you know, an application that looks like it's appropriate for that low diff, you know, making a shallow pressure gutter or need high volume. We can get the quotes, and if anybody wants to email me, I can get them to you now. It'll probably take me just a couple of days, because I still have to coordinate with them on lead times. But if it becomes one of those situations where once they're in and you know that they meet a certain requirement for you, then we could start to, at least in low numbers, stock in that body size to give you something, you know, that's not 20 to 26 weeks of waiting to finally be able to get. So,
and what's the max rating of the HP Flow Max?
The one that has 600 class flange connections is 1480.
Okay, so it's got 300 and 600 flange capability.
Yes. And quite frankly, they call it a FlowMax, but because of the way that the pressure chamber is built, like the actuator and stuff, it looks like a different cat to me a little. You know, I mean, yeah, it looks like a FlowMax, but it's you know, it's a new design.
So does it look like a PF then?
I'll show you. I'll send you the material on it. I have brochures and stuff. I don't think it looks like anything. Oh, you're gonna pull it up, Drew? All right, Drew's hooking you guys up right now. And if not, what do we have on our? We should have on our website now. But I have all the stuff you might want on it.
Tony, we have a lot of the furniture already. We've been looking at them for transmissions already, so we have a lot of information.
There's a good picture of it. Well, it's small. Yeah. Can we get it bigger?
But we're not seeing the picture.
Well, he's working on it. I was telling the guys, we did some, like, for the field guys, we did a training yesterday for Texas Gas Service, so I was more digging into a lot of this stuff, you know, from their perspective yesterday. But I was telling them, you know, Drew's here because I'm technologically challenged. You know, I can still remember vividly the days when we had television set with a tube that the way when it started messing up, you know, you start getting static or lines or something on it, that the solution was to beat on it. So he doesn't want me beating on the computer. Can they see that yet?
Yeah, you can see those.
Okay, so there's a comparison of the normal FlowMax and the HP FlowMax. The other one looks like, you know, I don't know how old you all are. I'm 61, but Lost in Space was one of my favorite shows as a kid. And that looks like that robot. Danger, Will Robinson. Okay, anything else on the FlowMax you'd like to get answered? So basically, you're not going to probably see these in working monitors because, I mean, when typically in 150 class sets, which this is, you're not usually having to make that kind of you know, two-stage cut and have them back each other up. You're just having them back each other up. So it's usually the single reg, the relief, the working monitor, and it could do the same flow control business because we're talking about a rotork actuator mounted on the stem that's just causing it to open or close on its own flow input and override what the pilot's wanting to do with the valve pressure-wise. So. All right. Would this be a good time to transition to talk a little bit about the flow safe, Tony?
Absolutely.
Okay. All right. So just to close the loop on this, then there actually is a traditional sizing chart in the brochure for the FlowMax. So you don't have to get into valve spec to get an idea of the capacity it can do with certain pressure cuts. That's all, you know, kind of like laid out in a kind of a traditional fashion. But also, if you just select like we were doing in valve spec, the flow safe category instead of flow safe, the FlowMax category instead of flow grid, then all your sizing will be of the, you know, the FM series up through the 6-inch size. Okay, get this stuff out of the way, and I'm going to pull in some